Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Dianna Dini.
Hey, Dianna. When we first got on the phone or on Skype, we're using Skype to record, and we were chatting a little bit. You asked the question, and I thought it was kind of from left field. It was like, so what software are you using these days for reliability stuff? And I hadn't thought about that in a long time. I'm like, I use whatever works, kind of thing.
Whatever's available.
Yeah.
Yeah, I was, talking with other reliability and quality people and kind of looking on Reddit and asking around what people would use. And I had some standard software packages that I would use with clients for years, but now I don't really have access to those anymore. So I was just kind of poking around and asking what people are using these days.
Jeez. I'm thinking of when I first started, it was a software package by Ban. And they're a big consultancy group, and they had their own data analysis package. And it was marvelous. But then right about that time, Mathematica came out. So my first thought was, well, I just use Mathematica, which is kind of the Swiss Army knife for anything mathematical. And their stats packages have gotten better and better and better over the years. But that's not a common use one, and it has a pretty steep learning curve. So.
Yeah, I have not used Mathematica, but they're still maintaining it and putting out new versions.
Oh, yeah. I mean, they stopped publishing the book because it was like 3 feet deep kind of of how to use it. It does just about everything. And every year they, layer on another whole pile of stuff. But what do most people use? In my experience, the bigger companies, it's funny. Some of them say, well, we have Excel, so you only use Excel. And then I say, all right, let's do a random number generator, and let's plot it by, every second, every third, every fourth number against each other. And after about, after 20, you can see patterns in it. It just is not a random number generator. And it says, kudos to you for actually trying to get a random number, but don't use Excel. And the other things Excel does is cost you more time to set it up and run it than it does, and you'll probably get it wrong, than it does to buy ReliSoft and just make it happen. And
that's what I found too, is most people like to use Excel, and it is difficult to set up. And I always have to look up the functions and make sure I'm using the right Excel function for what it is I'm really trying to do.
Yep.
And it is cumbersome, especially with plots. Yeah.
The default stuff is just hideous, in my opinion.
So if someone wanted to do a random number generator, and I hear you what you're saying about Excel, but they didn't have a statistical suite, do you have a go-to online random number generator? Because there's lots of websites out there now for that too.
There are a lot of websites out there. The ones that basically just have a random number table that they copied from the 1800s or something.
Yeah,
or the 20s.
Yeah, I have those.
Just use one of those books and just work your way down it. And it's those. The reason I say this, and I have it's one of my tests for software packages, is that one of my graduate courses was on random numbers. It was the whole course. And the whole course was showing how bad Excel was in so many different, it was our poster child for all the tests that you could run. Any software. I mean, if you have a seed and you put the seed in again, you're going to get the same sequence. It's just not random. And computers can simulate it or get close. And the better ones will go out, a million digits before it will show a pattern or a repeat, but it's not random. It just can't be. And for most practical purpose, if you need to take a random sample and you got 10 things you got to take, unfortunately, most people think that their brain is the best software package for that. And they look at the clock and go, oh, it's 10 seconds after. Let's use that as a round number. And then they look at the clock again. Oh, it's 20 seconds after. And they take a sample. And they soon realize that it takes them 10 seconds to pull a sample every time.
Yeah.
That's not random, guys.
No, it's not random.
But we digress. There are software packages in Excel over the years has gotten way better. So if you're doing, if you got a lot and you want to draw 25 samples, it's probably just fine. It's just don't pick the same seed every time. Don't pick, don't be cautious of it. Create 100,000 random numbers, like creating your own book, and then work through it. Don't redo it every time, because you're going to pretty much get the same thing every time.
Well, that's good advice.
But Excel is probably the easiest answer for your question. Is that most people for software, for quality and reliability stuff, are trying to use Excel. Unfortunately, I would say next, at least in my experience in seeing clients and stuff, it's either Minitab and or ReliaSoft. And ReliaSoft's kind of pricing themselves out of the market. And it's a business decision. I remember S Plus software years and years ago, which was based on an open source S prior to open source being a term, but they commercialized it and were selling that. And it was very much like R. It's based on the same basic logic and platform. But they priced themselves out of the market. They went only to the financials companies, and it was like $30,000 for a year license for the software. So I was like, no, I'm not doing that anymore. But then R became very, very popular and supported. So
yeah, and R is open sourced.
Yep.
Right.
Yep. And I like it because one, it's a programming language essentially, and people in the community create packages. So if you wanted to do an XBAR R chart, there's probably a dozen different packages that you can load in that, have all the bells and whistles, or no bells and whistles, or just really basic. But you can get it once you learn how to open R and find a package and install it. It takes like 10 minutes to explore a new package and get the job done. And you got a plot, or whatever, but its plotting is very versatile. It's all kinds of stuff that comes with a programming language. It's very powerful, very versatile, and a steep learning curve. There's no doubt about it.
Now, with the packages in R, now if I'm buying something off the shelf like Minitab and ReliaSoft, and those are two that I've used a lot in the past. But when using R in the packages, since it's open source, is there any kind of validation that's done on the output? Like I had worked for a company one time that was doing FMEA, and you can multiply the 3 columns: severity, occurrence, and detection to get an RPN, or risk priority number. And they didn't want to use they had a template for this that calculated the RPN number. But then someone said, you shouldn't use that because you haven't validated that.
This must have been a medical device company.
It was, yes. So now you're mentioning R, and it's open source, and there's different packages. So when you're looking at the packages, are there specific authors that are a go-to, or do you just check them out yourself? How do you think about that?
Well, for me, and it might be just a habit of mine since I've been using these programming-based type packages or languages or software programs for so many years, is that I open up one of my favorite textbooks. It might be an example of, I could do it by hand out of the book, but it's going to be a pain. So I'm opening up software. So then I run that example through, and am I getting the right answer in the software?
Okay.
And so and I know you can be more rigorous about how do you, quantify or qualify a software package or algorithm. But I mean, doing 3-number multiplication, that should not be too terribly difficult to figure it out, given the range of values between 1 and 10.
And I had to multiply them all out by hand, which is just introducing human error now, because now you have somebody multiplying it out, but
Well, I would
Anyway,
have asked, do you have do you use Excel? Oh no, we can't possibly use that. It never works. FDA doesn't believe Excel works, but it depending on which way the wind's blowing, things like that can happen. But yeah, I get that. It's the hard part is that I see it too many times on the flip side of that is somebody will use a software package and never check it, never understand it. Like you mentioned, you check am I doing a P norm or is it R norm or is it which function am I using here for this, this variable? It's like every time I talk about standard deviation, I say there's a difference between a sample standard deviation and a population standard deviation, and people's eyes glaze over. And it says, well, what does your calculator do? And they don't know. And they get a number and merrily go off and do what they're doing. And I'm like, this is a problem, guys. You can't just believe whatever comes out of your software or out of your calculator.
Yeah, especially statistics and everything. There are so many requirements, or what's the word I'm looking for?
Well, the assumptions. Yeah.
Yes, the assumptions.
Yeah.
The assumptions going into any kind of statistical calculation and result. And no matter what software I'm using, I do find I have to go through, especially Excel, and just check the assumptions. Well, how is it calculating this?
Mm-hmm.
What values is it using? And I do sometimes, I have to crack open my stat books and look up the assumptions of whatever I'm calculating.
Mm-hmm. Well, I do that. Oftentimes, it's just the way I make sure I'm using it correctly. I've made plenty of mistakes using software, and I've seen way too many people using it blindly. Well, we got a 2. Well, you realize that if you calculated that it's at 2 degrees Fahrenheit, you could touch it, but it's white hot. So I think you're missing a few digits.
Yeah.
So I see it too many times where there's a blind faith that, well, it's software, it must be good, and without thinking through it at all. And that's beyond where most people go, is if we're using something, then they are assuming that it's a random distribution, or it's an exponential distribution, a constant hazard rate, or that of course it's normally distributed. Well, you have this machine at the end of it that's clipping off the tails. So I don't think your end result is actually normally distributed, because you're cutting off 25% on either side. So, I don't think that applies anymore, guys. But the software packages, in some places, it becomes, well, that's what we have, so we have to use it, independent of whether it's a good or not. Excel or Minitab or any package has limitations. But there are, it should be like a tool. Are you using the right hammer or screwdriver or wrench for the job you're doing? Is it the appropriate software that actually helps you versus getting in the way? And then there's software packages that just boil my blood, is the ones that go, oh, we can help you calculate MTBF any way you want, and and they're not kidding. You can get whatever number you want. Just fiddle with all the dials until you get the number you want.
A good engineer, would say your audio goes up to 10. Well, I can make it go up to 11.
That's right.
Right.
That's right.
Yeah. No real difference in the back end.
That's right. But there's Relax, which I think got bought and it's somebody else now. And I even knew the chief engineer for that software, the chief statistician that was running it through conferences and stuff. And I was like, why do you create all this stuff and you do all the right math, but then you produce just the MTBF value, MTTF values? And he goes, well, that's what customers want. That's how we sell it. And he says, yeah, it's frustrating, but they don't want to produce a Weibull or a gamma distribution as the output, and into the block diagrams. It's too complicated. Customers don't want that. I was like, oh, this is heartbreaking.
Oh, that seems like an opportunity, though, especially for statisticians that know the value of the calculations and the outputs, that they could, even if the customer just wants a number, just have the software automatically populate out the Weibull plot, or some other values as a way to help educate the consumer.
Well, that's the trick. And I found it when talking to the folks at Reliasoft is they steadfastly did not add residuals or make them easy to get. So if you have a regression analysis, which was plotting a Weibull curve, one of the most fundamental ways to check it is to look at the residuals. And they just says, no, customers don't need that. And they're not asking for it. And like, isn't that fundamental? Isn't this an opportunity for you as a software company to help people actually do good analysis? And he goes, that's not our business. It's just basically, we sell software that do what they ask us to do. And I thought that was years and years ago, but they still don't have, as far as I know, residual analysis.
Yeah, I'm a little surprised at that because they had great educational outreach, 3-day seminars that I attended one of those.
And they were good because they said, let's teach you about doing Weibull data analysis, life data analysis. And we happen to be using our software, but it wasn't 3 days of how to push buttons on their software.
That's right.
It was about the theory and the statistics and when and where to use it and stuff like that. And there were all a bunch of statisticians, PhD statisticians, but they just didn't go into the next level of make it useful to help people do a better job of what they're doing. All of the steps to make sure that your software package is giving you a result that's meaningful, all the validation stuff. They took it up to, here's your beta and eta, and here's your plot. Have a good day. It could be complete crap, but nobody would know.
I think that's something that would be valuable in a statistical software because I want to do it right. Mm-hmm. And we, like we mentioned earlier, we look up our textbooks to make sure that we're going through all the steps and getting all the outputs that we need to evaluate. So to have a partner in statistical people creating software that would help assist customers with that would be kind of awesome.
It really would. I agree with that. It's one of those that I think the software companies have looked at it and say, we're not teaching people how to be statisticians. People that know statistics use our software as a tool. And so we're providing the tool. We're not providing the knowledge and nuances and stuff because that opens Pandora's box from their point of view of all the different nuances and subtle assumptions they're making within the software programming. Does it fit your circumstance? There's no way they can know.
That's true.
So
it could be a liability thing too, huh?
Well, yeah, I think so. I think part of it is let's not provide more than what they're buying is also part of the thought process. Now, one other thing I ran into, and this was, I don't know, about 10 years ago, I was doing some calculations and I just wasn't sure that I was doing this right. And, it was just one of those pit in my stomach going, this doesn't look right. Mm-hmm. And I was in Reliasoft and then I opened up, I think I had a sample package back when they used to hand out CDs all the time of item software. And I got a different answer for the same data set doing a regression. And I double checked, is it, rank regression or is it multiple MLE? What is that? Maximum likelihood estimator. And, double checked a bunch of stuff and I got different answers. It wasn't over the top different, but it was like second, third decimal point. It was different. I'm like, that shouldn't be. And so I called a friend of mine and he had a couple other packages and he got different answers. So at the end of the day, we ended up with like 8 different software packages and we got 8 different answers.
Oh, no.
The first 2 digits were the same. So, we're all close, but it spoke to the point that if your data is a fringe case or some of the underlying assumptions don't line up, different packages treat it differently. The underlying algorithm for rank regression or multiple maximum likelihood are essentially the same, and they're all pulling from the same pool of algorithms. But the way it does calculations, where it rounds off, where it stores it, how many digits, and so on, it matters, especially when you got a pretty sensitive case. But it was one of those things that I was like, if your gut's bothering you a little bit, one, that's good. It's a good sign that you're, squinting at your software output going, does this really make sense? Is this close to what it should be? That's a good thing to do. And then two is then go check it. And the unfortunate part is so many people use the software and never do that. They never learned the basics or the fundamentals or never did it by hand, for example. And they have no basis to judge whether this is real or not.
Yeah, the practical output versus just a statistical output.
Yeah. Yeah, there's all kinds, and I know Chris Jackson rails against software packages that create confidence intervals that fold back on themselves. It's like, yeah, that doesn't make sense.
So with things like Minitab and ReliaSoft, which I've used, they have a pretty strong, I think, there's statisticians that are working and training people on how to use it. So if you have a question, you reach out to them, you get a statistician. Now, R is open source, but I'm getting the sense that there's a lot of statisticians working on those packages.
Oh, yeah, definitely.
So how do you find the support structure for R? Is it a community that's helpful and knowledgeable?
Yeah, by and large. I mean, don't ask questions that somebody could say, well, let me Google that for you, because there's so much online. There's so many of the basics. If it's how to use this feature or function or package, those things are well documented in dozens and dozens of sites, especially the basic stuff. But every now and then you run into something that's like, how come I can't get from here to here? I'm trying to get this kind of output on this example, but here's the code I'm using and it's just not working. I've gotten great answers really fast. And it's the same with Mathematica. There's an amazing community behind that. I find that I stay with software that has that community behind it. Sometimes it's the support team is just over and above. They do a great job. But oftentimes it's the community that just provides that. And I find that with R. There's a email list. It's that you can post a question to, and you'll get answers in the next day easily.
Oh, that's pretty fast.
Yeah. And I know there's websites and other places that you can ask questions and they then whip out a new article, but the response isn't as quick. And there are forums. I know for Mathematica there is. I'm thinking of R. I think it was the software or email list.
Yeah, and I know that I haven't looked into Mathematica, but I know for R there are some independent people too that blog about their experiences with the software and troubles they run into. And they have like a frequently asked questions section too.
Yep. And there's so many how do I create a histogram? And here's all the packages and here's, the top 5 packages to create this. And there's review sites and how-to sites and stuff like that out there. There's a bunch of support out there, which brings up the idea is that we should probably create our own, because of the reliability quality realm of it, is a niche within R, which would... It is a learning curve for that package to get it up to speed.
But it sounds like once you've cultivated the packages that you need, because most people are doing routine things, the same thing over and over again. Yep. So once you do have those packages and you've tested them out with your textbooks from the examples in the textbooks, then you would have a pretty powerful suite of tools. Yep. That you could use.
Oh, definitely. And you could leave Excel on the side. Don't worry about it anymore.
All right, Fred, I'm convinced. You and some other people, I'll crank open R. Now, when I was studying, I learned C++. Was what the new thing was. Like everybody was ditching Fortran and going to C++. So how is it? Do you know C++? Is it a little bit comparable to R?
No.
No, okay.
R is way simpler.
Well, that's good.
Yeah. It's, if you want to create a plot, the command is probably called plot.
Oh, I see. Okay.
It's pretty common sense most of the time. And then there's all the variables. You want a XY plot, you want this kind of plot, and you can add all kinds of cool stuff on it. But you can use it on the command line, not even creating a program, but just building it. So I'm going to make some random numbers and I'll assign that to a variable, and then I want to plot that. So let's say I create 100 random numbers and I put it in X. Well, if I want to do a histogram, the command is HIST, parentheses, put the X in the parentheses and it gives you a histogram. And you can do it step by step and build the variables and then manipulate them and go on with it. And then you can say, all right, well, I want to put a title on this. Well, then I repeat the last command and add the element that says I want a title in this, and stuff like that. So you can iteratively interact with the software real time and develop what you want. And then once you get the set of code that creates that histogram that you want to do every week, well, now you can save that and just make it a function on your own and use it on your own. Or you can get a package, which is the next step up, which is somebody's gathered a bunch of these functions and documented them and put them in a package for you. So if there's something that the software doesn't do, or you don't know where to find somebody else that is doing what you're looking for, you can create it yourself. Or you can use it like a calculator, saying, hey, I need to multiply these two vectors together. Let me do that quickly. You could do it in Excel, but I find R just faster.
Yeah, I would imagine R would be faster. And then the other one you opened with was Mathematica.
Mm-hmm.
And is it similar, or it's more curated, or how is that different?
Well, it's got a better user interface. It's got all kinds of stuff on it. But again, it depends on which set of. It's like packages, but it's the different commands within it. It's not as. It's the right level. There's machine language programming where you're dealing with zeros and ones and stacks and stuff like that. And then there's a Fortran and C and those languages that manipulate those elements, but have more common sense. I want to do a sort, so there's a command for sorting. Then there's higher order languages like R and Mathematica and these other ones that are, you don't see stacks. You don't worry about memory allocation. That stuff's all done in the background. So it's Mathematica's like R in that you can use it as command line and iteratively build it. You can build functions that are unique to yourself. You can create scripts or whatever they call it that are like packages that'll repeat the set of commands. You can even create standalone documents and websites that have interactive calculations in it. It's sort of like a super duper PDF, but with Mathematica built into it. It's pretty bizarre what they can do. But it's also one of these tools. Mathematica is grown to where it's doing everything from artificial intelligence to pattern recognition and photographs to, anything at all that has to do with mathematics at all. It's in there.
See.
It's just massive what it can do these days. Whereas R, it has a very broad appeal. One, it's free. And so university folks have been developing stuff for this for a decade or more.
Yeah.
And so there's tons of applications in it. But I find that it does the basics and even more advanced statistics really, really well. And so it's got a lot of versatility. But I like it just as a command line, as a replacement to my calculator that, even if I had a nice graphing calculator, it's limited. It's really hard to dump numbers into my phone, basically, for, my desktop calculator. Even as nice as it is, it doesn't take imports very well.
I haven't used a graphing calculator, and I can't tell you how long.
Well, you shouldn't. We shouldn't talk about that. But the idea is that the software packages need to be something both that you're familiar with, that you have an ability to know that it's working and where its limitations are, and that it actually saves you time. And that's the tricky part. As opposed to, well, that's what we have, so we have to use it. Well, that often doesn't even make business sense. And So, and then the other ones, well, whatever the software tells me, that's the answer. Well, that's just dangerous.
Yeah, those are two common pitfalls with statistical software.
So, if you're listening to this, well, what software are you using? Let us know. Send us a note. What package you're using and why you're using it. And if you're have to use Excel because your boss won't let you buy anything else or use anything else, well, I'm sorry to hear that. I'll apologize right up front. But if you'd like to get in touch with us, please do. We certainly enjoy hearing from people that are listening to the podcast and getting questions and ideas and suggestions from you. It makes figuring out what we want to talk about useful to you. So head over to accendoreliability.com/go/SOR, and you can find a widget to record a message to us, an audible message, or leave us a text or a text message. You can also find Dianna and I and the other hosts of the show on LinkedIn or on our About pages on Accendo. So plenty of ways for you to join the conversation. Geez, now I'm all excited. I want to go find some new software packages. Go play with them.
Well, I'm going to start digging into the Mathematica and R, I think.
Okay. Well, I'll have to send you over the link to my webinar I did on intro to it. That might help you get up to speed.
That would be good. That would be good to post as part of the description of this episode, too.
Yeah. No, good idea. All right, cool.
Yeah.
Well, thanks for bringing up the topic, Dianna, and we'll have fun rest of your day.
Yeah, thanks, Fred. Pleasure as always.
All right, talk to you soon.
Bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.